Hello everyone, welcome to the series where we build the clone of PDF.ai app. And this is the second video of the series. And alright, let's begin. So this is where the fun really begins. This is where we are going to start to understand what's going on behind the scenes. Now, like I said, I'm going to tell you how this application is working. You do not have to memorize any of this right now because we are going to eventually build a clone of this application. And at that point, well, then you'll get a really in-depth explanation of everything that's going on. So for right now, just kind of high level overview. Okay, so I'm going to show two possible ways of making this application work. The first way is not going to be that great. I just want to mention it, and I'm more into second way, which is a little bit better. So option number one for answering a user's question. So whenever user asks some question into the web app, we could take all the text from the PDF. I mean, all the text from every page, and we could send both these prompt of the chat GPT and just hope that chat GPT answers this question correctly. Now, like I said, this is not going to work out too well for a couple of different reasons. First, we can only send limited amount of text to chat GPT. um, Sorry, my bad. So first, we can only send limited amount of text to ChatGPT. If you send anything longer than that, ChatGPT is going to just gonna immediately throw in there, and I can prove that to you easily. If I go over a PDF and copy everything, and if I paste that to ChatGPT and put in my question, where does the word Amazon come from? Very quickly, we'll see that it goes into an error state. So let's try that. So I have this PDF open, which is talking about Amazon rainforest. So let's copy the entire content. Let's head over to Chat GPT. Okay, let's input the entire content which we got from the Wikipedia, and let's ask a question. Hey Chat GPT, where does word Amazon come from? Now, as you see, we got an error saying that the message was you submitted was too long. Please try something shorter. So, as I said, it's not a great way to achieve what we are trying to build. And very, yeah, we just got an error. It was too long. Now, even if we could put in as much as text as ChatGPT to ChatGPT as we wanted, maybe with future enhancements to the model, we'll be able to input more tokens, which we usually do not want because the chat models usually don't understand the entire context if you give a lot of text. So if there's a ton of text, it's likely that we end up getting wrong answers because it's much harder to understand or pull some discrete meaning out of all the text. So shorter messages are almost always better. And finally, the more text we send to ChatGPT, the more money we have to pay for each individual request. So at some point of time, it is really just a financial issue. We don't want to pay ChatGPT tons and tons of money just to answer few basic questions from a PDF. So obviously option number one is not that great. Now let's go ahead and take a look at option number two. So option number two, yeah, this is what we are going to be doing in our application, and this is also very likely what PDF.ai is doing as well. So everything begins when a user uploads a PDF. Whenever user a PDF is uploaded, all the text is extracted and divided into chunks. Now we then run an algorithm over each individual chunk to generate a summary of what that chunk is talking about. We then take those summaries and we store them in a database. Now this database is called vector database. We'll talk about that in much detail in next few minutes and further in next videos. So once we run, we generate and summaries and store that in databases. Step 1 and 2 occur instantly when someone uploads a PDF. After we've generated those summaries, we then kind of wait around. We wait for user to ask a question. So later on, whenever user does ask a question, we are going to take a look at the question. We are going to try to figure out what is it that he's talking about, and what we are going to look at all the text summaries that we have stored inside a database, and then we'll try to find the most relevant chunk of the text. Once we found the most relevant chunk of the text, we are going to send that plus the question asked by ChatGPT, asked by the user to the ChatGPT. Now this is the entire process, and which might give a little bit more meaning to it, because understanding what's going on behind these steps, yeah, that's what we are going to understand, why we need to use LangChain at all. Okay. Uh, so uh, give me 1 second. So step one, it's super simple. We just take um, all the text, we extract into one big blob of content, and that, so that all pages are together. Once we've got all the text, we then divide them into chunks. By default, usually we might use a chunk size of 1,000 characters. It might change based on the algorithm which we are using or based on our requirements. There are few algorithms, so there are few ways in which team people do is that they add some common content between each chunk, so that there is some understanding in each chunk. So let's say the first 1,000 characters are part of chunk one, then next chunk would have from character number 900 to character number 1,900. Third chunk will start from character number 1,800 to 2,800. So that ensures that we have some context of what's happening in each chunk. Now there are some consideration over what should an ideal length be, and of course that's something we'll discuss later on as well. Once we have these text chunks, we then start to do a little bit of magic, and this is where things start to get really interesting. So we take each of these text chunks and we feed them into something called an embedding creation algorithm, and based on the name of that, as you guess, this creates something called embedding. So let me very quickly tell you what an embedding is, because this is going to be super key topic throughout the course. It's going to be something we come back to very very often. So to explain, an embedding takes a string and turns it into an array of numbers. So as you can see, let's say if we pass some text chunk to the embedding creation algorithm, we'll get a huge array of numbers. It would be between the range of -1 and 1. These array of number, and usually they'll be of length 1536. So no matter what the chunk is, no matter what the size of the chunk is, it's always going to generate an array of numbers whose size would be 1536. All right. So and let's say, so now you can think of these array of numbers as distilling the raw and essence of what that text is talking about. So for example, if I feed in a text, Amazon rainforest is located at XXX place, then the raw and essence of the array would be talking about the same sentence. So I might get back a number that looks like the array of the numbers which I've shared here. Um, and each number inside the array is kind of a score that talks about what the text is really discussing. So maybe this is an example. This is not what the first number actually is, but maybe the first number is kind of a score of how what or x coordinate of Amazon rainforest. The next number might be talking about, let's say, where do potatoes grow. So it might not be related to each other. um, so it's just that the in these embeddings of these array of numbers, we kind of think of these as being scores that are discussing or kind of rating the raw essence of what the text is talking about. We can create an embedding of for any length of text. So we can make a embedding for a very short sentence like the one which I added in the current slide, or for a giant text, or even an entire PDF document. Whenever we put a chunk of text into an embedding creation algorithm, we are always going to get back probably a slightly different array of numbers. Slightly different array of numbers. So if I put in, let's say instead of Amazon rainforest is located, let's say I put in I feel great, I might get back an array of number that looks something different than what we are seeing in the current slide. And let's say if I just change it a little bit, instead of putting in I feel great, I put in I feel good, then the entire array might change. It would not look exactly as same as I feel great. And So no matter what the chunk is, what the content is, it's always going to return you an array of numbers whose length would be 1536, and it would be between the range of -1 and 1. Not only do they kind of help us understand what the chunk is of text is talking about, but they're also well an array of numbers. So that means we can do some math on them, and that ends up being really, really handy. So let me show you why in just a moment. So we are going to repeat the process for different chunks. Sorry, I missed that slide, I think. So essentially, when we repeat it for different chunks, we'll be getting different numbers. And once we have huge chunk, we are going to come up with a big list of embeddings. So for each chunk, we'll have a different embedding. Once we have generated that list of embeddings, we are going to store them inside a database. And we usually refer to these databases that are really specialized in storing in embeddings as vector stores or vector db. We can make use of very traditional databases like SQLite or MySQL or whatever else, but again usually we put them inside of something called vector store because they are very specialized for handling these embeddings and eventually doing a little bit of math on them as well. Okay, so now that's kind of a pre-processing step that we have gone over. So now we kind of fast forward to where a usual user actually submits a question. So a question might be something like, where does the word Amazon come from? Well, remember, we need to somehow find the most relevant chunk of the text that's related to the user's question. So we are going to go through that same. Here we go, right here, embedding process. We are going to take the user question. We are going to feed in the same embedding algorithm, and we are going to generate a embedding list of numbers, 1536 numbers, between the range of 1 and -1 and 1 for the user's question. So now we have got some kind of sense in this numerical format of what user's question is all about. We are now going to take that embedding. Here it is on the left hand side where we can see 0.6 minus 0.9, 0.94, etc. And we are going to as I said, we'll do some special math here, and which will go over in great detail over the course, to find these store embeddings. So what we'll do now is we'll compare these embeddings over the ones which we had generated for multiple chunks of text of the PDF, and we are going to find the chunk of text or the embedding that is most relevant to the user's question. So in this case, maybe the most relevant one we decide is the embedding number 3 right here. So if you see, it starts with a bit nearby. So again, we can't understand these numbers as is. There's some math which is being performed. But let's say, for the sake of the argument, that the embedding of chunk 3 is the most relevant chunk for the question which user has asked. So what we are going to do is we are going to create a prompt, and which will have the relevant chunk from the PDF along with the user's question. So what we'll do is we'll take the question, and with that the super relevant text from the PDF, which is the chunk 3, and we are going to create a prompt for ChatGPT. Uh, and I okay one. So what we'll do is we'll just say, hi ChatGPT, the name Amazon is arise from something which was the content of chunk 3, and we'll at the end ask also, where does the word Amazon come from. So now we have reduced the size of the content which we are passing to ChatGPT. Instead of millions of characters from a PDF, we'll just pass some, let's say, 1,000 characters of that chunk to the ChatGPT along with the question. Now there is a possibility that more than one chunk represent a particular question, and more than one chunk are very similar to the user question. In that case, again, in the future series, we'll see that we'll merge those chunks, and then we'll create a better question, a better prompt out of it. So here we did, hey ChatGPT, did you know that? And we talked about something about Amazon, and which is present in the third chunk, and we gave a message, and with that a question, okay, where does the word Amazon come from? So now we'll see that the answers from ChatGPT is very accurate. It will exactly answer from the content which you have passed, and which is going to be almost always true. and it will tell us where the word Amazon has come from. Now, well, ChatGPT is kind of the least interesting part in this entire system, because all ChatGPT really did was and like in the critical part of the PDF that we have just iterated over the critical part of the PDF, we just sent to it. So that's all ChatGPT did, but the entire pipeline which we have built is something which we are going to explore in the entire series. So that's the entire process. That is what is happening behind the scenes in the app from theoretical point of view. So now that we have got kind of understood this process, and we have got an idea of what embeddings are and how we are chunking the text and creating a prompt which is being sent to ChatGPT to answer a question from PDF, I think we are at a good stage that we go ahead and start with what is LangChain, why we are going to use LangChain, and what will it do in the entire process. So that's for the next video. Thank you everyone for joining and learning from this video. If you have learned anything, please do subscribe the channel so that more people are able to more views, more people get to see this video. And in the future we'll be continuing this series, which would have almost 120 to 150 videos, and we'll try to create exact clone of PDF.ai tool. So if you have not seen what PDF.ai does, please feel free to go to that website, see how it takes in a PDF, and see how well it answers the question. And we'll try to build the exact replica of it without having to purchase the premium of PDF.ai. Thank you everyone for joining.